Okay, hello everyone. Let us solve this question which came 2019 July exam. Okay, so look at that's question 1, section A. Given that matrix K is equals to 10, we have negative 2, 11, negative 2 there, find the determinant of a matrix. So to find the determinant, let's see, question 1, A, Roman numeral 1. So to find the determinant of the matrix, if let's assume we have letters A to D there, where we have matrix K is equals to A, B, C, then D. So to find the determinant of the matrix, the word determinant is abbreviated to DET, is equals to, determinant is equals to the product of the major diagonal. So this is the major diagonal I'm talking about. This is the major diagonal. Then we also have the product of the minor diagonal, which is this one here. You can see that. So to find the determinant, we have A times D, A times D minus B times C. That's what is called the determinant. That I'll find it. So A times D minus C times B. So this is a major diagonal, that's a minor diagonal. So if you put, in this case on matrix K, where we have K is equals to 10, negative 2, 11, negative 2, to find the determinant of this matrix K, determinant is equals to 10 times negative 2 minus 11 times negative 2. That's a times. Okay, so 10 times negative 2, we have negative 20, minus 11 times this like this, 11 times negative 2, we have the negative 22. Negative negative is a positive, we can't have two signs in between, so we have negative 20 plus 2. Negative times negative is a positive, plus 22. So when you have different signs, you have to subtract and get the sign of the bigger number. So the answer here, it will be positive 2. You see that, eh? The positive 2 there. Okay, so that's the determinant for the matrix K. Now if you go to question Roman numeral 2, it's saying that we find the inverse of matrix K. We find the inverse of matrix K. So what is the inverse of matrix K? How do we find the inverse? The word inverse is abbreviated to write the letter representing the matrix K with a power negative 1. That's the inverse. Now to find the inverse, we use the determinant. We first find the reciprocal of the determinant, or the inverse of the determinant. So the determinant, we had found it's a 2, where the reciprocal of this 2 is 1 over 2. So we are using this one. Instead of 2, we are using the 1 over 2. So the determinant is equals to 1 over 2. Then you open the square bracket there, and you start writing the numbers in matrix K. Now what we do when writing the inverse, the numbers in a minor diagonal, these, they change signs when writing the inverse. So here we had a negative 2, when writing here to be a positive 2. This is a positive 11, here to be negative 11. Then these numbers in a major diagonal, they swap. So 2, negative 2 go there, 10 will come that side. So we have negative 2, we have a 10. So this was a positive 11, it becomes a negative 11. That was a negative 2, it becomes a positive 2. You see that, eh? So these numbers, they have just changed its signs, then these have swapped their position. Okay, then you start multiplying what you have outside times what is inside there. So we have 1 over 2 times negative 2. So that is 1 times negative 2. We have a negative 2 over 2. Then again we have 1 times 2. We have a 2 over 2. 1 times 1 times negative 11, we have negative 11 over 2. 1 times 10, we have 10 over 2. Okay, and then you simplify where it is possible. 2 can go into negative 2, that's 1. So we have negative 1, then 2 into 2, that's 1. This one will leave a remainder, of course, so just leave it like that. Negative 11 over 2, then 2 into 10, that's a 5. So this is the inverse, which is in negative 1. Negative 1, we have a 1 there. We have negative 11 over 2. Negative 11 over 2. Then we also have the 5 that side there. Okay, so this is the determinant. This is the inverse for matrix K. Matrix K inverse is equals to that. So that's how we do it. That's how we do it basically.